Today we're going to learn how to install the EZ2209 with the TMC type stepper on the Octopus Max EZ version 1.0. So a couple of things I need to tell you. Obviously there are several steppers that are showing up here. You can see there are 10 of them total. Only 6 of them can do sensorless homing. So there's little pins down in here that activate sensorless homing. But what I'm going to do is I'm actually going to show you how to do sensorless homing in this video. So you're never, in the case of this stepper, going to use end stops when using sensorless homing. I have to emphasize that just so you are aware of this. So what we're going to have to do is first figure out how to install this, which is quite easy because we don't have to set any jumpers underneath. So if we pick this up, you can see there's a little bolt right here. So that's going to face you. So you're going to push this down like so, and the bolt side will be here. Now there's other things to consider being the voltage. So we're going to check the manual. So I'm going to pop this out for just a second so you can see what we're going to do. So we're going to go over to the manual over on the desktop, but first I'm going to show you the TMC configuration. So here's the data sheet for the TMC 2209. Obviously it can do stepper, it can do smooth running, but what we're interested in this particular case is the actual stealth chop, which is silent motor operation. Spread cycle obviously has a lot of noise to it, but I'm going to emphasize this one because most people want their printer to be quiet. So what we're going to do is we're first going to go over and we're going to search on the actual manual. Now I showed this in the basics tutorial, but I'm going to show it again. When you're on the repositories, you'll search for Octopus EZ Max. Inside here, you can download the zip and then extract it on your computer. Now, I already have this open for the actual manual. So I'm going to search on steppers. So I'm going to go next, and you can see we have stepper driver motors. Now, down here, you can see where the actual diag pin is for sensorless homing, which is right here. That's going to be a smaller size jumper, by the way. And then we're going to have either high voltage or regular voltage. I'm going to use the other 2 pins for the regular voltage for our motor power because I'm not using anything above 24 volts. So what we're going to have to do is place these jumpers in place. So back on the board, what I'm going to do is I'm going to grab, first of all, this jumper, and we're going to set the voltage up here by placing this jumper in place. Next, I'm going to have to grab the sensorless homing jumper, which is extremely tiny, and I'm going to have to place that right here on the actual pins for it. So now we can place this back in. Note the position of the bolt, and that's all set. So we're going to connect here for our actual connection for USB, or excuse me, not USB, for the NEMA stepper motor over here. And then we're going to connect power. So power is going to be a little bit different. I'm going to have to pop this open, and obviously they've already outlined voltage ground, so we're going to have to keep that in mind when we install this. So I'm going to take out a screwdriver, and I'm going to install one side over here. Notice I'm using ferrule connectors for safety. And the other side for ground over here. I'm going to slide that in, tighten it down. Now I also need to connect board power. So we're going to do the same. So we're going to check to see what it says, positive, negative. And we also should check this in the actual diagram for the board to see if there's any contradictions. So I'm going to loosen these up. Double check it again. So negative over here. And then positive being voltage over here. Okay, so I'm going to close this for safety, and we'll double check to see what the actual diagram says before we'll power anything up in the system, because the power is off currently. So let's go back over to the desktop for a second. I'm going to pull up the actual pinout diagram. As you can see, it says negative on top, positive, negative on top, positive. So voltage, voltage. So let's go back and double check. Looks good. So the next thing that we're going to do is we're going to have to set up the firmware. So I'm going to grab this. I'm going to connect the USB right here. And then I'm going to place this in the computer. Now you may obviously hear a beep. So let's go over to the actual desktop. Now, as you can see, I have nothing open at the moment, so I'm going to click over here, do open folder. I'm going to go to my downloads folder and open up the 2.1.2.1.2.1, and then I'm going to select the folder. Now, inside here, I have to set up the motherboard, so I'm going to go to source core boards.h, and I'm going to search on Octopus. Now it's the 7th one down, so we're going to go to the 7th one. We're going to highlight this, copy this, then we'll minimize core and source. Remember, we're actually, in the previous tutorial I talked about in the basics tutorial how to handle this, so keep that in mind. So we're going to go to configuration.h, we're going to search on motherboard. We're going to highlight where it says ramps and paste our board. Then we're going to change the serial port to -1. And then what we need to do is actually set up our steppers. So we're going to search on A4988. Let's do that again with the actual 4 instead of a 2. There we go. And we're going to search on the TMC2209. So we'll copy that and we'll paste it right here. That's all we have to really set up. We may have to reverse the actual direction it goes in. So if you search on direction, or let's see if we can find it real quick here because there's multiples of them. Okay, I may have just gone by it. So here we go. So let's see. We can tell which direction it's going in. I believe it's close by here. Let me find it real quick here. There's an invert direction, which is what I want to search on. So let me search on invert. Maybe this will make it easier. So this is inverting the logic of the end stops. That's not what we want. So let's get down to where it actually is. So here is a way to invert the actual direction. You can say that it's going one way or the other by using this. You can also invert the direction down here. This is preferred, so the stepper direction will go one way or another. So kind of ignore what I set up here. This is probably better. So let's go over to the advanced configuration and we'll search on 800. So I'm trying to find the actual stepper for the X. This is where you're going to set your normal currents. Now keep in mind there is right here micro steps. This goes from 0 to 256. It's actually 16 to 256. It's the doubling of this number. So right now for this stepper, everything is set by default correct. But Over on the configuration.h, if we were to go back and search on the A4988, you'd see down below here, there's actually a setup for the actual steps, if they didn't move it on me, which it looks like they may have. So let's search on steps per. Sorry about this. And there's no results. So we'll do mm for millimeters. Or we'll do better yet, 80, 80. There we go. So this will bring you right to it. It's default steps per unit now. So what you're going to see right here is that this is 80. That's the default configuration when you have 16. If you were to increase this, say you wanted to do 32 here, you would have to then do 160 here for your x-axis. If you were to increase it, let's say to 64, you would then need to go back over here and change this to 320. And the reason I'm emphasizing this is a lot of people have trouble with this concept. These are proportional between the two. So you're going to have to keep that in mind when you use this. So let's set up the actual sensorless homing. So in order to do that, we have to search on sensorless homing. But before we do that, we're going to set up TMC debug. Sorry about this, guys. It's been a while since I've done this. We're going to change the monitor status so that we can actually see it. And we're going to also have to do TMC debugging in a second place, which is here. And this gives us a command set in G-code so we can check things of M122 to see the status of the end stop. So let's now set up sensorless homing. So sensorless homing should be someplace nearby. There it is. So we're going to hit Control / to remove the comment again. And then down here you can see that there's an install sensitivity of 8. That is not the actual sensitivity for our stepper. Up here you can see that the actual one for the TMC 2209 is actually should be, in this case, 125. That will be the optimal setting. It may vary like 120 or 130 depending upon your configuration. You can adjust this, but you're going to have to iterate through. So now that we have that set up, we need to set up our build. So I'm going to go to platformio.ini, but I also need to point out one more quick thing about power supplies. If you do use this, you're going to have to possibly change for spread cycle your power supply type. So hopefully if I can find it here real quick, I wanted to point this out for optimizing spread cycle chopper. In the case of our configuration, we want to use 24 volts. So to do that, we're going to actually have to copy this if we use chopper. In this case, we're not using it, but I'll change it anyway so you can see. So we'll just paste it right over this. That is our particular setting. But let's get back to the INI configuration. Currently, it's set up for the Mega 2560. So what I need to do is go to my INI folder, find our chipset, which is STM32H7, search on Octopus, and it's not going to be the first one that we come across. This is incorrect. It's actually this one down here. So I'm going to copy that, minimize the INI, then I'm going to find the Platform IO environment, paste ours in, do a clean rail quick right here, and then I'm going to do a build which is going to build our build. So over in here, you can actually watch it while it builds. So let's check this real quick here. Hopefully I haven't screwed this up. So you can see that it's allegedly building. So I'm going to terminate this task and let this go. So on occasion, obviously, I screw up when I press too many buttons too quick. But what it's currently doing is it's getting ready to build. Inside here, you can actually watch the actual build. And while this is occurring, if you see yellow, that's just a warning. But if you see red, that means that there's a build error. My first step when this occurs is go to the very first error that I see that's in red and go to that. But in this case, the other thing I like to do before that is build a second time. If it does work the second time, it means something in the build is building out of order, because part of the build is already encapsulated in here. So yellow is a warning, so you can ignore that. We're not probably going to see red in this case. So what we're going to have to do now is wait on the actual firmware.bin to appear. And so it's real close because we can see the EIF, but there seems to be some kind of issue. And that issue might be that I pressed something while this was building, but let's see if it's there. So it already exists. So it says unable to find matching CMS or CMSIS DAP device, no valid JTAG. So this means that I probably have some other issue that's unrelated to this. But if we build the second time, we can double check. It should build quicker because everything exists. But that error might be related to loading of the actual board being, I may have pressed the forward arrow, which is upload, and that's why you're seeing that. So let's find the actual build by right-clicking here and doing Reveal in File Explorer. Now we already have our previous load from the other day, so all we have to do now is right-click and then send it to this drive. Now I need to remind people that if it loads correctly, it'll be renamed to this. If you want to reload it on another system with the same configuration, you'd rename it to this. Successful loads always go to firmware.cur and should have a file size. So I'm going to remove this from the computer and now install it in the board. So I'm going to place it over here. And then I'm going to power this up in a moment, but I'm not going to use the USB like I did last time because we don't want to reset this. So we're going to plug it in and it will load the firmware. Now you may hear a beep on the computer once it loads. So let's plug it in and see what happens. Hopefully there won't be any smoke. So as you can see, the board is flashing. So now what we need to do is go to Pronterface and see what's going on. So let me try switching over to Pronterface real quick here. It's going to take a second because I want to make sure that you can see the full visual. There we go. So inside here, obviously I'm covering the actual configuration for the G codes down below in here. But there's a line that I'll show you real quick so you can see on the desktop, which is right here. This is where I'll be typing commands like M122, but I can't do that until we're connected. So let's see if it shows up here. It does show up as our port, but if we had trouble finding it, what we could do is go to Device Manager. And sorry, this is showing on the other screen, but I'll bring it over. So right here for ports, you can see that it only has one port that's showing up, which is weird. So what I'm going to have to do is try and connect. It's not connecting, which is interesting. So what I'll have to do is go back over to the desktop and see what's occurring. So on the desktop, I'm going to power it down first, power it back up. We hear a beep as if it's connecting to something. So let's go back over to the computer and see what's going on with Device Manager. So Device Manager came back up and we have the port right here. For some reason it looked like it was hidden a second ago, or maybe we had a power cycle after the load. So let's try and connect. Let me actually show you what's going on. Sorry about that. If we go over here to Device Manager, when we're in Device Manager, we have to go to Ports. It's now appearing right here, so we're good there. So let's try and connect. It says the printer is now online. So let's try the M122 command. Obviously it's behind the screen that I'm about to show you, so I'm going to do it first so you can see it. You can see that it says everything is okay. So now let's try and test this. So what I'm going to do in this case is I'm going to try and home first. So that's going to be over in here. So let's click this and see what happens. Hopefully the sensitivity is correct. So it looks like it's homing, and there's no grinding, so we're good there. So let's try moving it out 100 and seeing what happens. So that's good. 100 more. So that's perfect. So we didn't have to invert the direction. I'm homing it again just to verify, but at this point I want to thank you for taking the time to watch my tutorial, and also thank my patrons and the people on PayPal for their donations. And I'll put a thank you note at the end of this video. So everyone take care, be safe, and I'll talk to you later.